Hi, Assalamualaikum. My name is Muhammad Asing Tuduslan.
Hi, my name is Nurul Ayu Natasha binti Mat Rani.
Hi, my name is Wan Karini Nasai binti Wan Safil Arini.
In this video, we are going to present about rate of change. First thing first, we need to know about the learning outcomes in this topic. So the learning outcomes in this topic is to determine the rate of change of one quantity as the rate of change of other quantities is known. In calculus, sometimes there is a situation where we need to find the rate of change of one quantity related to other quantity. Usually, this rate of change are respect to time. For example, um, the rate of change of y, we write it as dy over dt. Meanwhile, the rate of change of x, we write it as dx over dt, which is all these two equations is respect to time. Remember, the rate of change is always usually respect to time. So if the rate of change of a quantity is positive, thus the quantity increases with the respect to time. On the other hand, when the rate of change of a quantity is negative, so the quantity decreases with respect to time. So now, let's proceed to procedure for solving related rates problems. There are 5 of them. We should follow all the 5 steps in order to get the right answer for each question. So, step 1, we need to determine two main characters here, which is the rate of change that is known as given in the question and also the rate of change that need to be found. In step 2, we need to construct a formula or an equation that relates variable in step 1. We also can draw a labeled figure that illustrates the variable in first step. This method will help us a lot in understanding the question deeper. Okay, in step 3, we need to differentiate implicitly both sides of the equation with respect to time. In step 4, we must substitute the known rate of change in differentiable equation in step 3 before. And lastly, we can finally solve the remaining rate of change.
For question 1, we know that the height of the water is twice the radius. So it means h is equal to 2r. And the formula for the volume of conical water tank is V is equal to 1 over 3 pi r square h. And then we must substitute h is equal to 2r into the formula. Therefore, V is equal to 2 over 3 pi r cubed is proven. From question number 2, it states that the rate of water flows out is 15 cm cubed per second. So it means dV over dt is equal to negative 15 cm cubed per second because it flows out. We have to find how fast is the radius of the surface of the water changing at an instant when the height of the water is 4 cm. So it means we have to find dr over dt. From question number 1, we already know that h is equal to 2r. So, we just have to substitute h is equal to 4 into the equation. So that we get r is equal to 4 over 2, and we will get 2 cm for the radius. Using the equation that we got in the previous question, which is 2 over 3 pi r cubed, we must differentiate it into 2 pi r square. Next, when we get dv over dr is equal to 2 pi r square, we have to substitute the value of the radius. So it will be 8 pi. So how can we get dr over dt? dr over dt is equal to dr over dv multiples dv over dt. From the equation, we have to substitute the value of dr over dv and dv over dt. We know that dv over dr is 8 pi, so it means dr over dv is 1 over 8 pi, and dv over dt is equal to negative 15. So, the radius of the surface of the water decreases at a rate of 5.8905 cm per second.
Next, for step 1, from the question, we have the information of dv over dt, which is 10 cm cubic per minute, and then we need to find the area of the base. So, we need to find dA over dt. In step 2, the volume of the conical pile is 1 over 3 pi r squared h. Therefore, V is equal to 1 over 3 pi r squared h. In this step, we should have equation that relate V and A, but the formula of conical pile volume only give us equation that relate V and H. However, we still can use this equation first. And then, if we look at the question, the radius of the conical pile is half of the height. Therefore, R is equal to H over 2. And if we replace R with H over 2, we can get pi H squared. Pi H cubic over 12. Next, in step 3, we need to differentiate implicitly volume respect of time. And here we can get 3 pi h squared over 12 dh over dt. And if we simplify it, we can get 4. So, pi h squared over 4 dh over dt. Next, in step 4, we need to substitute dv over dt with 10 and h with 5. This is because the height of the pile is increased when the pile is 5 cm. So, we need to replace h with 5. Lastly, for step 5, we can find dh over dt. And here, after we simplify it, we can get 8 over 5 pi. But we need to find dA over dt. So, from this diagram, we can see this is the circle. So, the area of the circle is pi r squared. Therefore, area of the base is pi r squared. And we already know r is h over 2, so we can replace r with h over 2, and we can get pi h squared over 4. After that, we need to differentiate implicitly area of base with respect to time, and we can get here 2 pi h over 4 dh over dt. And after we replace h with 5 and dh over dt with 8 over 5 pi, we can get 80 pi over 40 pi. And here we can simplify it. And lastly, we can get 4 cm squared over 4 cm squared per minute. Therefore, the area of the base increases at the rate of 4 cm squared per minute.
So, in conclusion, rate of change is always respect to time. We can determine the rate of change of one quantity that depending on other change of other quantities by applying these 5 simple steps in every equation.